So next on stage we have Andrei Petrescu, CTO at CloudHero. He leads the DevOps team at CloudHero and has been working with cloud native technologies since 2017. He's been involved in numerous migration projects to Kubernetes, while also being a certified Kubernetes administrator, Google architect, and AWS professional architect. In this session, he will tell us why a lift and shift to Kubernetes is the path towards application modernization by telling the story of how CloudHero migrated a PHP application from bare bones VMs to a managed and auto-scalable setup on Amazon EKS. He will go through the legacy setup stuff, including the application and infrastructure deployment, bottlenecks, and security. Andrei?
Awesome. Thanks a lot for a nice presentation. It means I don't have to get into too much detail on my side for myself. Yeah, so basically we're gonna talk about why lifting and shifting to Kubernetes is the way to go, and also like a little star with public cloud. But we're gonna talk about that later in the presentation. So as said about me, I lead the DevOps department at CloudHero. We are a company that specializes in DevOps stuff, mainly cloud migrations, Kubernetes administration, and we are AWS Advanced Partners. As stated earlier, we are running Kubernetes in production since like 2017, when the version was 1.7 at that time. We started playing around with it, 1.6, and when we were confident enough that it is the way to go, because we had to migrate from a Docker Swarm setup, we just went with it, and it has been successful until today. I'm also a teaching assistant at University Polytechnic of Bucharest, where I also took my bachelor degree, and I put my email and my LinkedIn on the slide. Just if you have any questions after the presentation and you want to hit me up, please, I think LinkedIn would be the best place to go. So what are we going to talk about today? Well, we're going to talk about a customer of ours called Raffle, how we migrated their infrastructure to AWS and Kubernetes, how we modernized their infrastructure, how we containerized their PHP application, how and why we use managed services. We're going to talk a little bit about some advanced deployment techniques, about infrastructure as code, how we plan the migration, and a little bit we'll dive into security and how AWS helped us with that. So, I think every presentation or story about a migration is to start with a little bit of context about the customer that we're talking about. In this case, we're talking about Raffle. Raffle is a UK startup. They specialize in hosting competitions. Basically, what they do is, imagine you want to sell your house, for example. Your house is like £800,000. What you can do is either try to sell it through a website that specializes in that, or you can put it up for a raffle and you can have 400,000 tickets, £2 each. The math checks out, 800,000. And people can buy 1, 2, 5, 10 tickets, how much they want. And the competition ends at a set date, or if the tickets get sold like faster than the set date. And a lucky person wins your house. So it is a little bit of gambling, but they also are very keen on charities. They really talk with their hosts, and most of the raffles also give a part of the money to charities. So it was early 2021, and Raffle contacted us because they just started the process of modernizing. They wanted to modernize their application because it was getting more and more popular, and they needed the tools necessary to be able to handle this increased popularity. So how the infrastructure looked like when we began the talks with them? Well, their application was deployed on some standalone VMs on DigitalOcean. They were created by hand. If you wanted to create new virtual machines if a big competition came about. You had to, best case scenario, snapshot the VM, create a new VM, put the code. It was really unscalable. It was a static setup. It was more like with pets, not cattle, if you're familiar with this terminology. The security was questionable, and I'm going to leave it at that. And there was also like no centralized application configuration system. Basically, their application uses some files, like, for example, if you use Magento before, it's not Magento, but it's kind of like that, where it has a configuration file that when it starts up, it takes the file, it parses it, and then it uses that. But there was no way of actually modifying the file. So if you wanted to modify the file, you had to SSH to the servers and modify it by hand, which was not great at all. Also, they were using Jenkins to deploy, but it was like a really bare bones thing where you had Jenkins that would SSH to the servers and pull the code from the master branch. It was not a good experience, and kind of that is what was the situation at that time. So lots of things to cover and to make better. But you might ask, like, why is there a problem with that setup? I mean, it works. They were making money. They were turning a profit. Why just go through the process of a migration and all that stuff when you already, things work? I mean, if it works, it ain't stupid, basically. But Raffle kind of had, they had some high expectations for their platform, and they wanted to go to the path of microservices. So they had a monolith, a PHP app. They wanted to break into the microservices. They wanted to auto-scale, thing that basically they couldn't do in their old setup. They had to manually create servers and deploy the code there. They wanted a more secure setup because, I don't know if you know, but gambling applications need to have a good security. More so if you want to expand to other countries. They had the need for flexible test environments because in their old setup, they basically had like one test environment. If a developer wanted to test something, then the test environment was locked. You had to wait for him and then deploy your code. They also needed some advanced deployment methods. And what's funny about this, when I say advanced deployment methods, I actually mean canary deployments. They were kind of doing canary deployments, but how they were doing it was that they were creating a VM, they were putting it to the upstream of the load balancer, so you were kind of stuck with 5 V1s, let's say, and then a V2, and there was traffic, they were monitoring the traffic. If all was good, it would get it out of the upstream and deploy the code. This works, but it doesn't give you the granularity necessary. Like, because for example, you would send like 20%, which is too much for a new version of the application that you want to test. And also they wanted managed services because they didn't want to spend time worrying that some critical piece of infrastructure would fail on them. And they would much rather spend their time like developing new features. So when we started, we were like really hyped. We wanted to move things as fast as possible, but they were like, hey, stop for a second. I understand, so let's move it, but first, we're still like serving live traffic. We need some quick fixes that we must do on this old infra because they're pretty critical. And there were some critical problems. As I've told you about the manual stuff that they had to do, well, big ol' Ansible just put some scripts and it helped them modify their application config. Some security hotfixes, we actually configured their DigitalOcean firewall. We put the correct tags on the server, so it was like these privileges. And also we reviewed the alerts. A funny thing happened. So some alerts had wrong thresholds, some alerts didn't exist. I remember that on Friday, this was a Friday, like at the beginning of 2021, I set up on synthetics alert. So they had alerts for CPU, memory, but nothing to actually check that the website is up. And I put that alert on Friday. And Saturday morning, I was having my coffee and I get a phone call from PagerDuty saying that the site is down. but no other thing was alerting. So what happened? They forgot to renew their domain. It happens, and if the site doesn't work, I mean, customer support doesn't work as well, so it was good that we managed to put that there. And we got alerted and fixed it pretty fast. So after we did all of these, we had to prepare for the actual migration, and did some basic stuff in preparation. First one was containerizing the application, which was not that hard because the PHP version was recent enough so that we could just get a PHP-based image, look at the modules which were installed on the old infrastructure and install them as well in the container, and then copy the code. So like containerizing PHP applications, if they're new, it's not that hard. If it's PHP 5.5, then God bless you. I don't know, good luck. Next, even it seems a little bit redundant, we had to take a dump of the MySQL database and restore it to RDS. Even if it's the same thing, it brings, let's say, peace of mind to the developers of the customer that things will work out of the box, nothing needs to be done. We had to assess not only the database sizing, but the sizing of the whole infra, because either things would be over-provisioned because autoscaling didn't work and they just created servers to handle peak traffic, or under-provisioned because reasons. Next, and a very important thing, like half of every migration is communication from my perspective. And it was very important that we create a migration document. It was like a 5-page document where week by week, we would describe what would happen, like in as much detail as possible, so that everybody was in sync. So when it came to actually doing the migration and preparing for it, everybody was on the same page, and we don't waste time on chit chats. And also simulate AWS costs. This is very important. I mean, when you migrate somebody to not only AWS, but any of the big cloud providers or small cloud providers, you need to give them an idea of how much things will cost, because you can imagine things can be a little bit more expensive if you take like apples to apples, AWS to DigitalOcean, like money-wise. And we did that cost simulation, and also a very important thing, we simulated the network costs, which are very important. People miss that. But when you actually start doing the math and you put the network costs in, you'll be surprised in how it changes the bill. So we did that. Everybody was happy. We could go forward with the migration. For infra as code, we used Terraform. These were the basic modules that we used when we started the migration. So basically a VPC for networking, RDS for the databases, S3, Elastic Cache for their Redis instances that they were using for sessions, and they had a locking mechanism that they implemented in Redis. EKS for the Kubernetes cluster, SQS for the queues and IAM. We actually had a way of like, we created users and groups, and if you wanted a new user, you would create a pull request in GitHub, and if the pull request was accepted, you would get a new user in AWS. This is how the infra looked like when we first migrated, kind of like this as well. Now, not much changed. It looks a little bit complicated because I tend to overcomplicate drawings, but it's really not. Basically, the customer connects to Cloudflare, where he has the CDN and the WAF. Then the traffic is forwarded to an NLB in AWS. The NLB is connected to Istio, which I'll talk a little bit about after this slide. And Istio was just forwarding traffic to their monolith PHP app. You have the managed services, which I've talked about earlier. A general node group where you would have the apps, Istio, the cron jobs, the workers, and so on, that they would run on the general node group. And then you would have another node group which was running GitHub runners. So when we migrated them to AWS, the fastest way to set up the pipelines was just use GitHub runners because they were using GitHub. But we didn't want to have the workers on GitHub side because of one, security reasons, and two, cost reasons. We opted to have the runners on our infrastructure running in Kubernetes in an auto-scalable setup. So basically, that's where the CI was running in the CD. Nothing too complicated. And one thing to note here, the traffic was directly going to the internet. Usually when we do these kinds of setups, we opt for not gateways or not instances because it provides a more secure setup. In their case, we did two cost calculators, one with not gateway and one without. And they wanted to go without because of costs. But the firewalling is done so as nothing aside from Cloudflare has access to those virtual machines. So you cannot access the application if you're not going through Cloudflare. And also for observability, they are using New Relic, which I personally like very much. So they use it for logging, they use it for monitoring, and they use it for its APM capabilities. This is kind of how the infra looks now at a more high level. Basically, it has evolved from only the monolith. They started in parallel deploying a front-end app that is written in JavaScript, and using Istio, they would switch traffic page by page. So let's say, for example, this month I will create the competition pages and put them on the front end, and the rest of the traffic would go to the monolith, but the pages for the competitions would go to the new app. And this way they could like develop new stuff and just move traffic based on the endpoint. One important thing there to note is that some of the traffic goes through Cloudflare workers. So that thing there, this is Cloudflare workers. And why we do that is because we cache API responses for some of the routes, and we do that for performance reasons, because we had some incidents in the past where the database would be overloaded, and we found out that certain API responses can be cached like for 10 minutes and some of them like for 10 seconds. It doesn't matter. For example, the competition ranking or the host page where you see the competitions. After that, they started breaking some of the components. For example, they have a PDF service which is used in their CMS. They are working on an image optimization service because hosts can upload their photos and videos for their competition. But they usually, you can imagine, they upload like high quality photos. And these make the websites load slow. So they're trying to optimize them on the fly. And also they have some workers which are used to process things which don't need to be like real time. For example, sending emails. And all the M variables are stored in AWS Secrets Manager. So there's only one place where a developer needs to add environment variables for his application. A little bit about Istio and what it is exactly is, I would call it, if you look up the documentation for Istio, it's a service mesh, which means that theoretically it puts proxies on all of your applications in your infrastructure. With Raffle, we went the direction of only using it as an ingress because it's really performant, and it also gives us some features that are really good. For example, traffic shifting. This is the correct way to do canary because Istio allows you to only send like 1% of the traffic or 2% instead of 20%. So if something really is wrong with your new code version of the code, then you can catch errors or have a smaller number of people be exposed to your errors. It also can do path-based routing, which is used like to migrate to the new pages. And it has rate limiting capabilities, which was really important for us because Raffle has a bug bounty program, and hackers would spam the website trying to find vulnerabilities. And I would wake up at 4 a.m. with PagerDuty ringing because I had like 10x the traffic just because somebody was spamming the website. So we had to put the rate limiting in place. Okay, so what was the migration plan? Well, it's not so complicated. It's actually pretty simple. The first thing we did is we implemented Cloudflare. They didn't have it before, and we actually used it because, sorry, I'm gonna get a drink of water. We had to use it because when it comes to migrating, you have two choices. You either change stuff in DNS or you use something like Cloudflare that actually handles your traffic. It intercepts it. And when it comes to switching, DNS is not that fast to propagate. You want something that is like, you just put on a switch, you change something and it changes. And this is why we use Cloudflare. We also measure like dump and restore times. And why we measure this, as I've stated earlier, the communication is really important. The migration plan that we came up with was done in collaboration with the team from Raffle, and they opted because they could afford like a 1 hour maintenance window and the database was not that big. They just wanted to go through the dump restore route. They didn't want to have replication, the thing we usually do, but they just didn't want to complicate things. Because, yeah, I'll show you after that, they wanted to test stuff like with the maintenance on. We wrote the Terraform code with everything that was needed for AWS. We did a greenfield deployment. They tested. I'm still good friends with the tech lead that was working on the project. He's not working there anymore now. His name is Cosmin, and he was like really meticulous with how he wanted to test things. So after we did the greenfield deployment, he would like send one request to DigitalOcean, one request to AWS, and measure the latency and see if it's worth it. And it was actually worth it. We built the Helm charts that would help us spin up multiple environments. We created the pipelines. We configured the observability with Kubernetes, meaning that we installed the agents, the New Relic agents on Kubernetes. We set up Secrets Manager to have the environment variables there, so they were not like on Git or something, because it don't keep secrets on Git. We migrated the static assets from the DigitalOcean bucket to S3. And as I said, they did some smoke and performance testing on EKS with a snapshot of the database. Okay, so the big day came. It came a little bit later than we planned, because Cosmin wanted to do more testing. Yeah, this is how it actually looked like. I woke up at 5 a.m. I grabbed the coffee. It was actually my birthday, so I did the migration on my birthday, and I got a nice present that it worked flawlessly. We paused the alerts because you don't want to get alerts when you're migrating stuff. We set up a maintenance page on the production data center, and the same maintenance page on the AWS cluster. And what we actually did is that we had, instead of actually doing a deployment to the application to have the maintenance page, we had, using Istio, we had like a separate Kubernetes deployment where we had this app and we just changed the routing with Istio. And we had like another load balancer, which was internal, that was going to the application. So they could test while the maintenance was up. They would test through a different load balancer, which had internal IPs and through a VPN. So we dumped the production database. We restored it on RDS. We changed the endpoints in Cloudflare. They did some smoke testing. Basically, how everything went is that I remember when we started migrating, like Cosmin, who was the tech lead there, was like breathing really heavily because he's like a perfectionist for everything going right. And he was, I was hearing him in my headphones at 5 a.m. like he was really stressed out, but everything worked okay. And he organized the team that he had of developers, who should test what, and so on. And everything went smooth. And that is also one of the reasons why they opted for a simpler setup with just dumping and restoring the database, because they also were testing writing to the database. So if you just have a normal replication, if you write to the database, you kind of ruin the replication. There are ways to get around this, like you can have one-way replication from one DC to another and then another replication back, but you still ruin this replication. Like in case something happens, it's more complicated to change stuff. They just wanted to keep it simple. So after like an hour of testing, we finally managed to, everything was okay. We updated Istio to send traffic through to the actual application, and we on-paused the alerts, and everything was fine. We were finally on AWS and Kubernetes. We also had a rollback plan, which is like 4 steps. In case something happened, restore maintenance on EKS, dump artist data, restore it on old DC, switch the traffic back, and then remove maintenance page on old DC. So pretty simple, but you have to have one, like in case something happens. Usually it doesn't, but you don't know. It may happen. A little bit about the CI/CD pipeline that partially is still running because we are working on something else right now. So when we first migrated, as I said, we went with GitHub Actions, and one of the main benefits of Kubernetes, because the presentation is called like why lifting and shifting to Kubernetes is the best way to modernize your application. Well, this is a very good reason why it's super important, is that we packaged it into Helm. If you don't know about Helm, it's like a packaging software for apps that you deploy on Kubernetes. We created a stage environment, a production environment, and then we gave them a setup where they could spin up test environments on demand using Terraform. So if they wanted to test a new feature, they would just spin up a new environment, and it was all good, way better than the old setup. As mentioned earlier, we would have the workers on EKS. CI was running on all the pull requests and the push to master, and the flow of how the code would go to the environment said that on the test environment you could select what you want to deploy, basically anything. The master branch would go always to staging, and then for deploying to production, they would have release tags that they would create, so that in case of something, they could roll back to the previous version. Regarding Helm, we actually made a pretty simple Helm chart that would be suitable for all their applications, which comprised of PHP FPM, Nginx, cron jobs, and workers. And the nice thing about this is that whenever you want to create a new app, if you have a good enough Helm chart, you can just reuse the Helm chart and just create new values files. So that was the point, and that was why we wanted to migrate to Kubernetes, because it gives you the primitives necessary to develop faster than in a classical infrastructure. So whenever they would start working on a new microservice, they could just have what they had for the monolith engine, expand on it and work on it, and it would be great. So some improvements that we are working on right now regarding CI/CD. We are planning on and have almost finished migrating everything to Argo workflows for CI and Argo CD for CD. And the reason why we are moving away from the GitHub Action stack and are moving towards the Argo stack is that one of the reasons is GitHub's integration with Kubernetes is not that great. They still don't have like an official way of installing it on Kubernetes. If you go to the documentation, they just tell you like, okay, install it on some VMs, which was not the way to go for us. There is some software that was built on this that fixes this problem, but it's still not that great. So you wanted to opt for something which is really, really integrated with Kubernetes, which is Argo workflows. What I like about Argo workflows is that basically it runs everything in containers, and everything you can put on a container, like if you deploy a pod on Kubernetes, you can put in Argo workflows. So the options that you have are endless, and the auto scaling is really good, because if you put your resource request correctly, then auto scaling works correctly. And also Argo CD for CD, because I think everybody here heard about GitOps, and GitOps is, in my opinion, as well the way to go, because GitHub needs to be the source of truth. Right now, GitHub is, even if everything goes through a pipeline, you don't have anything that will tell you, let's say you modify something manually in the cluster, there's nothing that will tell you, hey dude, that's been modified, on the next run, these things will happen. That's how Argo CD helps, because it does a constant sync between GitHub and what you're running, and it tells you, it either like reverts it back to what is on GitHub. So if you're like a hardcore user, you can go with that. I wouldn't really 100% recommend it, because in case you have an emergency, you don't really want Argo CD to like revert your changes. But it also has the option to run where it just tells you like, hey, you're out of sync with what's on GitHub. Check it out and then and fix it. So that's why we are working on moving everything to this stack. Regarding security, this is something that AWS helped a lot, and also Kubernetes, because it's really easy, not only for this, but also for, like, as I said, for observability and the test environments. Kubernetes is really easy to integrate with lots of stuff. So you don't have to just reinvent the wheel. You have integrations with lots of things. And regarding security, they had some prerequisites that they needed to fulfill, because, for example, they were integrated with Facebook, and Facebook, if you do the login with Facebook in your app, then it has some security requirements that you must comply with. So basically, we use Trusted Advisor from AWS to check configuration mismatches or what isn't best practice. We use fine-grained security groups. We follow the principle of least privilege when it comes to network connectivity. We use Prowler, which is a tool that scans your AWS account and it gives you reports on vulnerabilities. We use Guard Duty. This is an intrusion detection system which notifies you if something weird is happening. For example, somebody is trying to connect to a port in your infrastructure and the IP is a bit weird, like it isn't where it should be from. We integrated with SNS, which is AWS's notification system, and we receive emails every time something weird happens. We also use Falco inside the cluster, and what this is useful for is it integrates with Kubernetes, actually works with Kubernetes, and it notifies you every time somebody, for example, opens a shell in a container. So if somebody somehow broke into your cluster and they open a shell inside the pod and they want to do some nasty stuff, then you will get an alert from Falco telling you that something happened, then you must check it out. We also use the ECR, which is the AWS Container Registry. We scan the images, like after every push, we scan the images to make sure that we have the vulnerabilities under control. We set a minimum password policy of 24 characters. whenever you create a new account, like the default password policy is somewhere around 8 characters, which, I mean, is secure, but come on, 24 characters is the way to go if you want to have something secure. And I think the most awesome thing that we did, and it's something that I also recommend that you do, is I think everybody knows about using MFA when you connect to the console of, let's say, Google Cloud or AWS or Azure. Well, we went a step further and we required that any user couldn't even use the CLI without MFA. And how we did that is, by default, nobody is allowed to do anything if they don't have like an MFA token. And when you want to do something at the CLI, you use a script which calls AWS STS with the MFA code. It gets a token and it uses that token to actually talk to AWS. And yeah, the other thing which is awesome about Kubernetes is auto-scaling. Going from a setup which was manually scalable to a setup which is just auto-scales based on if you have more customers on your platform, was a thing that really helped Raffle, and it helps them now. We didn't complicate things regarding auto-scaling. We did give them the possibility of having custom metrics for auto-scaling. So you can auto-scale stuff based on anything, and they do, for example, for the workers, they have custom metrics auto-scaling for that. But for the web app, we just kept it simple. They have like a CPU-based autoscaler. If the cluster detects that the average of CPU usage over the pods exceeds a threshold, then it creates new pods. They remain in a pending state, and then there's a component called Kubernetes, this cluster autoscaler, which creates new nodes. And this way, if they need capacity, they can have it in like 2 minutes, not half an hour. So it really helps, and it also helps whenever you want to do manual scaling, because there are certain situations where you know that you'll have a huge competition coming in like 4 hours. This gives you the possibility of just running like one command, kubectl scale deployment, and just put more replicas. And then in the back office, there are tools which make sure that you get your capacity transparently. So you don't have to create servers and deploy code and so on. It's much easier to do. I mean, I don't even need to do that. Like somebody from Raffle's dev team can do that if they want. So what were the results? Well, as you might have guessed, they have faster and more reliable deployments because they have a better way to test them using like fine-grade canary deployments. They have a fault-tolerant and secure setup. I don't think I had any like incidents since moving to AWS. To be honest, like the setup is very good. Nothing is failing. It is secure. Like when Facebook came and they wanted to have like a checklist, we just blazed to the checklist in like half a day. It was, I mean, even with RDS, they asked for an audit plugin on MySQL, which is in RDS is 1 click away. In DigitalOcean, for another customer, we had to, I don't even want to remember, but I think it took just 1 day to install. We had to move from MySQL to MariaDB, and in the MariaDB install an audit plugin and so on. It was a mess. Here you just push a button and you have the audit plugin, and Facebook is happy. And you have an infrastructure which, until now, it withstood all the huge raffles that they had problems with before because of infra reasons. So yeah, everything is good when stuff is working as it should. And with that being said, I thank you very much for participating. And please, if you have any questions, shoot.